Look up at the night sky. You see stars, galaxies, nebulae, the vast tapestry of our universe. For centuries, we've mapped and measured the cosmos, tracing its origins back to the Big Bang. But what if that's not the whole story? What if our universe is actually inside a black hole, nestled within a much larger, older parent universe? This idea, though it sounds like science fiction, emerges from the mathematics of Einstein's general relativity, the same equations that predict black holes. The Big Bang might not have been a beginning from nothing but the result of a process inside every black hole. If true, it forces us to ask, what is reality? Could our black holes be birthing new universes? This isn't just a thought experiment, it's a real line of inquiry in theoretical cosmology, seeking to solve deep puzzles like what came before the Big Bang and why our universe is so finely tuned for life. The answers may be hidden in the darkest objects in the cosmos. So let's journey to the edge of space and time, exploring black holes and the possibility that our universe is the beautiful, intricate interior of one. Our story begins with the simple act of looking up and wondering. To grasp how we might live inside a black hole, we first need to understand what a black hole is. Imagine gravity as a bowling ball on a rubber sheet. Mass warps spacetime. A black hole is an object so dense its gravity creates a bottomless well in spacetime. Nothing, not even light, can escape its pull. At its heart lies a singularity, a point of infinite density where physics breaks down. Surrounding it is the event horizon, a boundary of no return. Cross it, and escape is impossible. Not even information can get out. Everything that falls in, stars, gas, light, is trapped forever, its mass added to the singularity. From the outside we see only a sphere of perfect blackness. We can measure its mass, spin, and charge but never see inside. This isolation makes a black hole a self-contained region of space-time. And it's this very isolation that opens the door to the possibility. Could a black hole contain a universe of its own? Let's explore that idea. Here's the core of the black hole universe theory. The singularity at a black hole's center could be the seed for a new universe. Instead of physics ending at the singularity, perhaps it begins anew. A rebound, not a dead end. Physicist Lee Smolin proposed cosmological natural selection. Each black hole could spawn a baby universe with slightly altered physical constants. Universes that produce more black holes have more offspring, and over time universes like ours, fine-tuned for stars, galaxies, and life, become common. Our universe's physical laws may be the result of this cosmic evolution. We exist not by luck, but because we're in a universe optimized for black hole creation, and thus, for life. In this view, our existence is a natural consequence of a universe that reproduces through black holes. The cycle of cosmic birth and death continues. The expansion of our universe is one of the strongest clues to its origins. The black hole universe theory reframes this. Our universe's expansion could be the rebound from a black hole's collapse. The event horizon of a black hole and the cosmic horizon of our universe share striking mathematical similarities. Our universe's density and flatness mirror black hole properties. In this model, the Big Bang wasn't the beginning but a transformation, matter and energy reborn from a parent universe. Our cosmic story becomes part of a larger cycle of birth and death. Even the universe's accelerating expansion, driven by dark energy, might be a natural consequence of the extreme conditions inside a black hole. Our universe's history could be the echo of a dramatic creation. All of this builds on Einstein's general relativity, which revolutionized our understanding of gravity. But relativity breaks down its singularities, like the Big Bang and black hole centers. To go further, we need quantum gravity, a theory uniting relativity and quantum mechanics. Some ideas like loop quantum gravity suggest space-time is made of tiny loops, preventing true singularities. Instead, matter bounces at maximum density, turning a black hole's collapse into a new universe's Big Bang. The black hole universe model extends Einstein's work, asking, what if the end of one universe is the birth of another? It's a poetic continuation of Einstein's legacy. It's vital to remember, the black hole universe idea is speculative, not proven. Science demands testable predictions, but this model is hard to verify. The event horizon of our supposed parent black hole would block any information from outside. We can't observe the parent universe directly. We're forever sealed inside. Critics note the theory relies on specific black hole types and a quantum gravity bounce we haven't confirmed. Without a complete theory, it remains an elegant hypothesis, not established fact. Yet exploring such ideas pushes science forward, inspiring new research and deeper questions. Whether true or not, the black hole universe hypothesis expands our imagination and our sense of cosmic mystery. Sometimes the act of questioning is as important as the answer. So where does this leave us? The idea that our universe is inside a black hole transforms our perspective. We might be one link in an infinite chain, a cosmic matryoshka doll, universes within universes. Creation becomes an ongoing process, not a singular event. The same physics that made us may drive endless cosmic reproduction. Life could be a natural outcome in a universe born from a long line of successful, life-bearing universes. We may never know for sure, but the idea is powerful. It reminds us how much we have yet to learn and inspires us to keep exploring. The universe may be stranger than we can imagine, and that's a wonderful thought. As we gaze at the stars, we're part of a great adventure, piecing together the story of everything. Whether fact or fiction, the black hole universe theory enriches our understanding of what might be possible.